Welcome to the Geotech Center concept module on topology. My name is Wing Cheung. I'm an assistant director of the Geotech Center and also a professor of geography and GIS at Palomar College in California. Today we're going to talk about map topology and Geo Database Topology and their applications in GIS. So what is topology? As you can see on the screen, it is a collection of rules and relationships that, coupled with a set of editing tools and techniques, enables the geodatabase to more accurately model geometric relationships. To put it in plain terms, we can use topology to preserve spatial integrity between our features. To give you one example, let's say we have a layer of sidewalk lines that are connected, but one of those sidewalk line segments needs to be moved due to construction. We can use topological editing to make sure that those sidewalk lines remains connected even after we just edit one of the lines. The second reason is that topology can help us increase our editing speed and efficiency. For example, let's say I have a shared edge between two adjacent polygons, one polygon showing voluntary evacuation areas and the neighboring polygon showing mandatory evacuation areas. With topological editing, we only need to move that share edge, and that will instantly reshape both polygons, rather than having to edit each polygon one at a time. The third reason why we may want to use topology is we can use topology tools to help us identify errors in our data. For example, if someone gave you 500 lot lines to check, and you're tasked with checking to see which of them are not lining up with parcel polygons, you can use topology to show you where the misaligned lot lines are located, and the topology tools will also suggest ways for you to fix them. So, like I said before, the two types of topology we're going to talk about in this concept module are map topology and geodatabase topology. Let's start with map topology. Map topology basically comes in the form of a topological editing tool that is mostly used for editing edges that are shared between two polygons. And as you're making your edits, you want to make sure that these adjacent polygons remains adjacent to each other after making your edits. In other words, you want to make sure that you don't inadvertently create any gaps or overlaps as you're editing these shared edges between the two adjacent polygons. Map topology only persists temporarily in your map session. You can quickly create these map topology, like I said, for these share edge editing. However, if you were to add that same layer into a different map session, you have to recreate that map topology again in order to ensure integrity in your editing. So some examples of where we may use map topology includes if we have a polygon that is showing the ocean and another polygon that is showing land, and due to erosion, right, as the shared edge between ocean and land change over time, you may want to use map topology or these topological editing tool to ensure that as you move that shared edge that shows the ocean land interface, you're not introducing any unintended gaps. As another example, you can use these map topological editing tools to modify an edge that is shared between two different fields to again make sure that you don't inadvertently introduce editing errors when you're editing an edge that is shared between two adjacent polygons. Another type of topology is the Geo Database Topology. Unlike map topology, which, as I've said before, is mostly used for shared edge editing, right, where we're editing edges that are shared between adjacent polygons, with Geo Database Topology, you can choose from a variety of topological rules that I'm going to go over in the rest of this concept module. And unlike map topology, Geo Database Topology is actually an object that is stored in the Geo Database. So it will remain in the Geo Database permanently unless you go and delete it. However, for the features that you want to check against the rules that you have specified for the Geo Database Topology, all of those features must reside in the same feature data set as the topology, the Geo Database Topology object. So you can use Geo Database Topology, for example, to check for gaps in congressional district polygons, right, to make sure that the polygons in your layer must not have gaps. Or you can use Geo Database Topology to check to make sure that there is no overlap between different polygons that are showing different zip codes. So just as a quick review on what is a geodatabase or how things are organized in the geodatabase, as you can see in the graphic, you have a geodatabase, and within the geodatabase you can have a feature data set. As I've mentioned in the previous slide, when you create a geodatabase topology, it lives inside this feature data set, and all the features that you want to check against the rules that you specify for the geodatabase topology object must also live in the same feature data set. And the reasoning behind this is everything that resides in the feature data set must have the same spatial reference. This includes properties such as coordinate system, datum, and projection. With geodatabase topology, you can do much more than just share edge editing like in map topology. In fact, as I've said already, you can specify the number of rules to check your features against. Some examples of these rules include rules that are checked between features in the same layer. For example, you may have sidewalk lines all stored in one layer, and you can use topological rules to make sure that these sidewalk lines are not overlapping themselves. You can also check your topological rules against features that are stored in multiple layers. Let's say you have one polygon that is showing areas of active wildfires, and another polygon that is showing areas that are safe from the active wildfires. These two polygons should not overlap with one another, right? The active wildfire polygon should not overlap with the polygon that is showing areas that are safe. As another example, you can check your topological rules against features of different geometries that are stored in different layers. So you could have points that are showing fire hydrants in one layer, and you can say that those fire hydrant points must be covered by water lines that are stored in another layer. So just to very quickly go over the different properties that you'll encounter as you're setting up a geodatabase topology in ArcGIS. First of all, you have to give your topology object a name. This object, as I said before, will be created in the feature data set within your geodatabase. Then you need to specify the cluster tolerance. And the cluster tolerance can be best understood as a distance where, or the minimum distance that two features need to be apart from each other in order for those two features to be considered legitimate features with different locations. In other words, two features, let's say two fire hydrants, needs to be at least 0.02 feet apart from each other in this example in order to be considered two fire hydrants that are at different locations. If you have two fire hydrant points that are any closer than 0.02 feet from each other, they'll be moved automatically to coincide with one another during the topology validation process. This automatic movement of our points and lines in these extremely small cluster tolerance distance can help fix some of the minor imperfections in our data before they are validated or checked against our topological rules. Then we also have ranks, which are attached to the different features that are participating to our in our topology. And the function of ranks is whenever there is a discrepancy between, let's say, two features that are not lining up, the feature of the higher rank will control the movement of the feature with the lower rank. So in this case, since survey monument has a higher rank than lot lines, if there's a discrepancy between the location of survey monument and lot lines will be moved to coincide with the point locations of the survey monuments. Then we also need to specify which feature classes will be participating in our topology. And again, remember that only feature classes that are in the same feature data set as the topology object can participate in the geodatabase topology. And lastly, we need to specify what rules do we want to check against those features or subtypes of features that are within the feature classes that are participating in the topology. To check the features in your participating feature classes against the topological rules that you have specified, you'll need to run the validate topology tool in ArcGIS. Once you run that tool, any errors that are identified will be added to the topology layer, and you can see them on your map. Keep in mind that the more features you have, it'll take the tool longer to run, and also the more rules that you specified will also lengthen the process. Now, as you identified your errors, and you edit your maps and features to try to eliminate some of those errors, those areas that you have just edited are now considered dirty areas. And dirty areas are basically just areas that have not yet been checked or validated yet, and they may contain errors. So once you have identified the errors, you need to fix them. And the easiest way to fix the errors that are identified by your Geo Database Topology is by using the Error Inspector tool in ArcGIS. As you can see in the screen, using the Error Inspector tool, you will receive a list of errors that ArcGIS found when it was checking your features against the rules that you have specified. And you can preview where those errors are found. And when you click on the Fix tab, ArcGIS will also suggest some potential solution for fixing those errors. So you can use the suggested fixes that's in the Error Inspector tool, or you can also manually edit your features to try to eliminate those errors. Keep in mind, like I said in the last slide, whenever you change or make some edits after you have validated your topology, those areas that you just edited are now considered dirty areas because those new edits have not yet been checked by ArcGIS. So this is a summary of the process. You built your geodatabase topology. You used a geoprocessing tool to validate or check your features against those topological rules. Using the Error Inspector tool, you can review the errors that are identified. Then you can fix the errors either manually or using the suggested fixes in the Error Inspector tool. With everything that you edit after your last validation, those are areas that are called dirty areas since they may potentially have mistakes in them. And that's why you need to go and validate it again to make sure that they don't have any errors in them. In summary, we have talked about two types of topology in this concept module. Geodatabase topology, which is permanently stored in a geodatabase, but it can only work on layers and features that are in a feature data set. However, you can choose from a variety of rules to check your features against. Whereas map topology, is created in the map and is temporary and not stored anywhere. However, with map topology, you can use it to check features that reside anywhere. It doesn't have to be in a geodatabase or feature data sets. But unlike geodatabase topology, which has a list of different rules you can choose from, map topology is mostly used for shear edge editing to make sure that adjacent polygons stay adjacent. And with respect to validation or checking, the checks occur in map topology instantaneously as you're editing those features to make sure that those neighboring adjacent features stay adjacent to each other. And in terms of error prevention and fixes, again, that also happen instantaneously, because if you're using topological editing, it will prevent you from making any edits that will introduce gaps between your adjacent features. Whereas with geodatabase topology, you only check your features against the rules that you have specified when you run the geoprocessing tool, and then you'll fix any identified errors after the validation process. Thank you very much for reviewing this concept module, and please feel free to check out the Geotech Center website for additional concept modules. Thank you.